So, okay, students, welcome to the session. So, we were doing properties of the matrices, and we have seen few properties. I didn't discuss all those properties. I have taken into consideration only those properties which we will use in the subsequent text whenever they are required. So, now the next stage is what we will continue for some numerical questions based on finding out the inverse and the verification of the properties which we have already discussed. So the example is what? If A is this and B is this, then verify AB inverse is equals to B inverse A inverse. This is the property which we have discussed, and this is known as the reversal law. So what we will do here, let me explain the process. You should try to find out these values yourself, because in all the questions either we will add up two matrices or we will multiply two matrices, or we will subtract two matrices. We will use the process of addition, subtraction and multiplication of matrices. We are not going to use any new thing. Whenever we are going to use any new thing in any question, I will explain it myself, right? So here what you have to do, you have given two matrices. See, A is given and B is given. What you have to verify, you have to verify AB inverse is equals to B inverse and A inverse, right? So what you will do, see, A, B are given. A inverse, B inverse will exist when determinant of A is not equals to 0 and determinant of B is not equals to 0. You can find out the inverse of a matrix only if its determinant is not equals to 0. So determinant of A is not equals to 0, A inverse exists. Determinant of B is not equals to 0, B inverse exists. See, check this first. A is the given matrix, this. Determinant of A is coming out to be 11, hence A inverse exists. Clear? So A inverse exists means calculate A adjoint of A. Adjoint of A, you know how we will calculate the adjoint of A of a matrix of order 2 by 2. Adjoint of A is this, therefore A inverse is given by the formula adjoint of A divided by determinant of A. So this is the formula to calculate the A inverse. So A inverse is coming out to be this matrix 1 upon 11, 7 minus 2 minus 5 minus 3. So this is A inverse. Likewise, B is this matrix. Determinant of B is coming out to be minus 2, non-zero. Therefore, B inverse exists. Similarly, find out the adjoint of B. Clear? As we calculate the adjoint of A, we will find out the adjoint of B. And if adjoint of B is there, we can calculate B inverse, and B inverse is coming out to be 1 upon minus 1 upon 2, 4 minus 3 minus 2 minus 1. So we will calculate A inverse, B inverse, both are with there. The right hand side is what? The right hand side is B inverse, A inverse. Multiply these two matrices, B inverse with U, A inverse with U, minus 1 upon 22, this matrix, because this is 11 and 2 1 upon 22, multiply these two matrices and the product of these two matrices is coming out to be this. This is taken as equation number 1. Now what is left? The left hand side is left. In the left hand side, we will calculate AB inverse, right? So to calculate AB inverse, first find out the product AB. Multiply these two matrices to find out the product AB. Then write down its determinant. Its determinant should not equals to 0. Only then AB inverse will exist. See, AB is this, right? This is the product of this. Determinant of AB is coming out to be minus 22. It is not equals to 0. Therefore, AB inverse exists. So, if AB inverse exists, we can always find out the adjoint of AB, and the adjoint of AB is coming out to be this. You can use any one of the two methods to calculate the adjoint of a matrix of order 2. So adjoint of AB is this, therefore AB inverse by the same formula, AB inverse will be what? AB inverse will be equals to adjoint of AB divided by determinant of AB, right? So we are using this formula. This is equation number 2, and from equation 1 and equation 2 both matrices are same, therefore AB inverse is equals to B inverse A inverse, right? For the sake of practice, you can take any two new matrices and try to verify this property, then you will understand how does it work. The next example is what? This is also the property of the matrices. Let A is equals to this matrix. Verify adjoint of A inverse is equals to adjoint of A inverse, right? What is the difference between these two? See, the left hand side is what? Adjoint of A inverse. This is your left hand side, and the right hand side is adjoint of A inverse. You know the difference between these two? This is the inverse of the adjoint of a matrix, right? And this is what? This is the adjoint of inverse of a matrix. Clear? What does it mean? Adjoint of a, this adjoint of A inverse means first find out the adjoint of a matrix, and adjoint of a matrix is itself a matrix, then calculate its inverse. And this is what? This is adjoint of A inverse means find out A inverse as a matrix, then take its adjoint. Then we will denote it as adjoint of A inverse, right? See, we are given here the matrix A is like this, then its determinant is coming out to be 24, right? 24 means it's non-zero, therefore A inverse will exist. Clear? So if A inverse will exist, we will find out the adjoint of the matrix this. If adjoint is there, then we can determine the A inverse, and A inverse is coming out to be this matrix, right? This is A inverse. What we want to calculate? We want to calculate the left hand side. A inverse is this matrix, and adjoint of A inverse means take the adjoint of this matrix. See, what I told you, A inverse is this matrix 1 upon 4 minus 1 upon 6, 1 upon 8, 1 upon 12. This is the inverse of a matrix, but it should be taken as a matrix. Now take its adjoint. We will denote it as adjoint of A inverse, right? Because if this matrix would have been A, we will call it as adjoint of A, but here this matrix is A inverse, therefore it will be denoted as adjoint of A inverse. So its adjoint of A inverse will be what? 1 upon 12, 1 upon 12, 1 upon 16, 1 upon this. You know how we can find out the adjoint? By changing the first diagonal elements flipped, and the second diagonal element should be multiplied by minus sign. So you will get this adjoint of this. Now after this, what we have used here? Now we are using here the basic definition of the matrices. We calculated this adjoint of A inverse, we have calculated. Now what they are doing, adjoint of A, this is the A inverse, adjoint of A into adjoint of A inverse should be equals to what? This is adjoint of A and this is adjoint of A inverse. Just now we calculated, multiply these two matrices and the product is coming out to be identity matrix. In a similar way, if the order is reversed, adjoint of A inverse is multiplied with adjoint of A, even then in this case the product is coming out to be identity matrix. So what does it mean? If you recall the definition of the inverse of a matrix, A, B is equals to identity, then what does it mean? It means B is equals to A inverse. Right. So see, adjoint of A into adjoint of A inverse is equals to adjoint of A inverse, adjoint of A is IT. So this value adjoint of A inverse should be equals to transfer this adjoint of A inverse, right? So by using the properties of the definition of the inverse of a matrix, we can prove this property also, right? Like this is somehow a new example, right? Let A is equals to this matrix, find A inverse. There is nothing to do in this case. A is simply a matrix, this, find its A inverse. So A is a matrix of order 2 by 2. First check whether its determinant is 0 or non-zero. Its determinant is non-zero, then find out its adjoint, and then use formula to find out its inverse, that is adjoint of A must divide by determinant of A. So I think you can calculate the first part very easily. If A is this matrix, find its inverse. See, this is a matrix, its determinant is this, right? And the value of the determinant is what? 3 minus 16, that is minus 13, not equals to 0. A inverse exists, right? So A inverse exists means we will calculate the cofactors. So A11 the cofactor is 1, A12 the cofactor is minus 2, A21 is the cofactor is minus 8, A22 is the cofactor is 3. Now the matrix of the cofactors, take its transpose, so you will get the adjoint of A. So adjoint of A is coming out to be 1 minus 8 minus 2 and 3, right? Because the matrix of the cofactors will be what? A11 means 1, A12 means minus 2, A21 means minus 8, A22 means 3. This is the matrix of the cofactors and its transpose will be adjoint. So what you will get? 1 minus 2 as the first column, minus 8 and 3 as the second column. So what is this? This is the adjoint, right? Now A inverse is being calculated by using this formula. So what is our A inverse? See here, A inverse is coming out to be minus 1 upon 13, and then this matrix 1 minus 2 minus 8 and 3, right? Now let us see here onwards. What is portion 2? In portion 2, and verify that A inverse is equals to 1 upon 13A minus 4 upon 13I, where I is a 2 by 2 identity matrix. So simply means, what does it mean? It shows that the inverse of a matrix, that is A inverse, can be written as 1 upon 13 times of A minus 4 upon 13 times of I. Clear? So see, A is coming out to be this. We have to show that this equation is satisfied for this inverse. Simply this, right? So from here, this can be written as 13 of A inverse. This is equals to what? This is minus, multiply this minus inside, minus 1, 2, 8, minus 3, right? This is the value of 13 A inverse. Now what you want to prove? Your equation is A inverse is equals to 1 upon 13 of A minus 4 upon 13 of I. Now what you will do? You can take 13 common. So this equation can be written as 13 A inverse is equals to what? 13 A inverse is equals to A minus 4I. Now look at equation this and equation this. Here 13A inverse is equals to A minus 4I. Here 13A inverse is equals to this matrix, right? So the left hand side of both equations same. What does it mean? The right hand side must also same. So if we calculate the value of A minus 4I, if the value of this A minus 4I is equals to this matrix, then our result will be proved. Clear? 13 A inverse is equals to A minus 4I. This is equation 1 and this is equation 2, for example. Here 13 A inverse is equals to this matrix. So if we show that the value of A minus 4I is equals to this matrix, then our result will be proved. See, what is the value of A minus 4I? A is 3, 2, 8, 1. This is A, right? 4I, you know 4 is a number, I is an identity matrix. So 4I means 4, 1, 0, 0, 1. You will get here 4, 0, 0, 4. This is the meaning of 4I. So this matrix is 4, 0, 0, 4. And so A minus 4I will come out to be 3 minus 4, this is minus 1. 8 minus 0, this is 8. 2 minus 0, this is 2, 1 minus 4, this is minus 3. Now see, the value of A minus 4I is equals to this matrix. So this matrix and this matrix both are same. So what does it mean? 13 A inverse is equals to A minus 4I. Clear? Because this is the value of A minus 4I. From here, A inverse can be written as 1 upon 13A minus 4 upon 13 of I. This is what we want to show, right? Clear? This is a new question or good question, right? This is also another example. Verify that This matrix, it's a 3 by 3 matrix, so naturally the calculation will be somehow complicated. Verify that this matrix satisfies the equation a square minus 4a minus 5i is equals to 0, where I and 0 are identity and null matrices of order 3 respectively, and hence find A inverse, right? So this type of question, if you remember, we have already done. What does it mean? Verify that this matrix satisfies this equation. So this equation should be considered as a matrix equation. So if this matrix satisfies this equation, find the value of A square, means A into A you will get A square, multiply A with 4 you will get 4A, and 5i means 5 multiplied with 1 0 0 0 1 0 0 0 1. So 5i will be what? 5i you will get here as 5 0 0 0 5 0 0 0 5. I is an identity matrix of order 3 because A is a matrix of order 3. So A square, calculate here by multiplying A with A itself, multiply the matrix A with 4, you will get 4i, multiply 5 with the identity matrix, you will get 5i. Now simplify this equation, say this is A, so A square is this matrix, 4A is this matrix, 5i is this matrix. Now A square minus 4A minus 5i is equals to 0. Simplify, put the value of A square minus 4A minus 5, substitute all these values, its value should come out to be 0, right? This we have already verified. What is the second part? Respectively, hence find A inverse, right? So here now we cannot use now the formula to calculate the inverse of a matrix, that is adjoint of A is divided by determinant of A. Rather, here we have to find out the inverse of a matrix by using this equation, right? This is the difference. See how we will use this equation. Our equation is what? Our equation is A square. See, equation is A square minus 4A minus 5i, this is equals to 0. Now, what we want to calculate, we want to find out A inverse, right? So what we will do, we will multiply this equation by A inverse from its left side. See, the side left and right is very important because the matrix multiplication is not commutative. AB is not always equals to BA. So the position of the matrix in matrix equation is very important, whether it is at the left hand side or right hand side. Be careful. So we will multiply this equation A square minus 4A minus 5i by A inverse from its left hand side. Then see what happens. Say A inverse into A square minus 4 times A inverse into A minus 5 times A inverse into I, this is equals to A inverse into 0, right? Clear? So what you will get here? See, A inverse into A square. Let us simplify this. A inverse into A square. This can be written as A inverse, A square can be written as A into A, right? And if you take these two together, by the definition of the inverse, A into A inverse is equals to I. So what you will get? I into A. If identity matrix is multiplied with any matrix, you will get the matrix A itself. So the value of this is coming out to be A itself, right? Now minus 4. A into A inverse, again the identity matrix. Minus 5 A inverse into I, you will get here A inverse, and the right hand side, any matrix is multiplied with 0, you will get 0 itself. Now what we are getting here, see here you can find out A inverse very easily. Our equation is A minus 4i, A minus 4i minus 5A inverse is equals to 0. We want to calculate A inverse. So what is the value of C? Minus 5A inverse, now take it at the right hand side. What will be the value of 5A inverse? 5A inverse is equals to A minus 4i. Now calculate the value of A minus 4i. A is this. 4i will be what? 4i means 4 0 0 0 4 0 0 0 4. This is 4i, right? 5a inverse is equals to a minus 4i. A is this matrix, 4i is this matrix. Take the difference of these two, you are getting 5a inverse as this. So naturally, if 5a inverse is this, then a inverse is equals to divide this matrix by 1 upon 5. So 1 upon 5 times the same matrix. This is the inverse of the given matrix, right? Let us take this example also. This is also somehow different case. If the product AB is equals to this matrix 22, 6, 11 and 3, and Y is equals to, if AB is equals to this and the matrix A is this, then find the matrix B. Oh, good. What is given here? It's a very interesting exercise. We have given the product of two matrices AB. The product is given as 22, 11, 6 and 3, right? And the matrix A is given as 4, 7, 1 and 4, right? Then find the matrix B. This is what we want to calculate. Means if the product of A and B is given and out of the product one matrix A is given, then what should be the matrix B, right? Clear? So what does it mean? It simply means if we put the value of the matrix A, that is this 4, 7, 1, 4, this is the matrix A and this is the matrix B, and this is equals to this matrix 22, 11, 1 and 4. So this is what we want to calculate. What should be the matrix B, so that the product of B and the matrix A should equals to this matrix. Clear? This is what we want to calculate in this question, right? This matrix is given, this matrix is given, B is not given. And what we want to do, what should be the matrix B such that if the matrix B is multiplied with this matrix and the product of these two matrices should equals to the matrix lying at the right hand side. Clear? So see how we will prove it. We know that B can be written as I into B, because if any matrix is being multiplied with identity matrix, the matrix remains the same. So B can be written as I into B, where I is what? I, you know, I is an identity matrix like this, 1 0 0 1. So this B can be written as, in place of I, by using the definition of the inverse of a matrix. A into A inverse, you know, the product of the matrix and its inverse is equals to identity. So in place of I, we can write as A inverse, and this matrix B will remain as it is, right? Or we write like this, A inverse into B. No issue. A inverse into A, right? A inverse into A or A into A inverse, no difference. Now this can be written as by associative property A inverse of AB. This is the property which is known as associative property. So this is actually the value of B, which we can calculate. Now what we have now, we have the matrix AB. It is given as this. AB is given as 22, 11, 6 and 3, right? AB is given. A inverse is not with us, so calculate A inverse. Simply A is with you. Clear? A is with you. This is A. Find out its inverse. You will get the value of A, right? So what we will do to find out A inverse, this is the determinant and its determinant is 9. It is coming out to be non-zero, therefore the matrix is non-singular, hence A inverse exists. So this is the adjoint of this matrix, and you know how we can write down the adjoint. I have explained it in a very detailed way. And finally, A inverse is equals to adjoint of A must divide by determinant of A. So A inverse is coming out to the matrix 1 upon 9, 4 minus 1 as a first row, minus 7 and 4 as a second row. Now from this equation, this is the value of B. B is equals to A inverse into AB. A inverse we have calculated. this is your A inverse and this is your AB. So multiply these two matrices, the resultant matrix of this product will give you the required matrix B, and that is given by this. Clear? Let us take this case. Find the value of x for which the matrix A does not have an inverse. Case 1. In case 2, obtain A inverse when x is equals to 2. So students, I think it's a very simple case or very simple example. You can attempt it yourself. Find the value of x for which the matrix this doesn't have an inverse. You know, the matrix doesn't have its inverse if it's singular, means its determinant is equals to 0, right? The matrix don't have their inverses if their determinants are 0. So what you will do, right, this is the matrix, right? This is the matrix, write down its determinant, and this determinant must be equals to 0. Its determinant is coming out to be this. Simplify this, so value of x is coming out to be 1. So simply the determinant of the given matrix must be equals to 0 and solve it. What value of x you will obtain? Here x is coming out to be 1. So it shows that if x is equals to 1, means here in place of x if we put 1, then the value of the determinant will be 0 and this determinant will not have its inverse. Case 1 we are done, right? What about case 2? Obtain A inverse when x is equals to 2. So it's very simple. What you have to do, in place of x, simply put x is equals to 2 in the given matrix, and you can proceed as usual, as we have calculated many times earlier, the matrix inverses of the various matrices. Simply its determinant, calculate its determinant must be not equals to 0. And if determinant is not equals to 0, then you can go for calculation of the adjoint by calculating the cofactors of all the elements of the determinant. Then write down the matrix of the cofactors and then take its transpose to get its adjoint. And finally, to get it inverse, the adjoint of a matrix must be divided by determinant of A to get the required inverse, and that is coming out to be this. This you should attempt yourself, right? You can do it very easily. This is the next question. Find the value of the matrix X. Find the value of the matrix X satisfying the matrix equation this is equals to this. So I have discussed you many times about the matrix equation. The matrix equations are simply the equations in which in place of the variables we have the matrices, right? So here we find the value of the matrix X. So see, this is a matrix. So this X is also a matrix. It's not the sign of cross or multiplication. So what does it mean? The first matrix is this, the second matrix is X, and third matrix is this. So the question simply refers to if these three matrices are multiplied together, then the product of these three matrices should come out to be an identity matrix at the right hand side. So what should be the value of the matrix X? Clear? Are you getting the meaning or the theme of the question? In the left hand side, look at the left hand side. This is matrix 1, X is matrix 2, and this is the matrix 3. We have given three matrices, and product of these three matrices is coming out to be identity matrix at the right hand side. So what should be the matrix X? So that if all these three matrices at the left hand side are multiplied, the product should come out to be an identity matrix. Clear? This is our main objective. See how we will find out its solution. We have taken this matrix as A, for example, and this matrix as B, right? Let A is equals to the first matrix 2, 3, 1, 2, B is equals to the third matrix, right? Then what is the determinant of A? So determinant of A will be what? 2, 3, 1, 2, and it is what? 4 minus 3, this is equals to 1, this is not equals to 0. Means A inverse will exist because determinant of A is not equals to 0. Likewise, determinant of B is what? Determinant of B is this minus 3, 5, 2, minus 3. This is what? 3, 3 the 9, minus 5 to the 10. This is equals to minus 1, and this is also not equals to 0. So determinant of A is not equals to 0, determinant of B is not equals to 0. This shows that both A and B are invertible. If the inverse of a matrix exists, we call such a matrix as invertible matrix. So both are invertible means A inverse will exist as well as B inverse will also exist, right? Now, if we have taken this matrix as A, this is X and then this is B, so this equation can be written as C A X B is equals to, this is your identity matrix. Clear? Any doubt? See, this is our equation. This first matrix we have taken as A, second as usual X, this we have taken as B. So AXB is, this is identity matrix, this must be equals to identity matrix X. What we want to calculate? Here we want to calculate AXB is equals to I, we want to calculate the matrix X, right? This matrix. So how we will calculate X? If we remove A from here and B from here, we will get the value of X. Clear? Are you getting the what I want to say? AXB is equals to I. We want to determine this matrix X. So we can determine X how? If we remove this A from the here and B from here, only X will left. So we will get the value of X automatically. So what we will do, our objective is how we can remove A and B from this equation so that we can obtain the value of X. And this is the basic idea for introducing the concept of inverse of a determinant. So how you will do it? I have told you we cannot use the division process in case of matrices because division is not there in case of matrices. Therefore, we will use the concept of inverse of a matrix. See, this is our equation. We will multiply this equation from the left by A inverse. See, multiplying this equation from the left by A inverse and see what happens. A inverse of A X B is equals to A inverse of I. Clear? What we did? We have multiplied this equation by A inverse from its left. See, A inverse into A, this is I. This is X as it is, this is B, and this is equals to A inverse I. You will get here A inverse. Clear? X has been removed from our equation, right? Similarly, we can remove now B. So I into X, you will get here X B is equals to A inverse, right? Because I into X, you will get X, right? So XB is equals to A inverse. So from this equation AXB is equals to I, we have removed A, and we removed A by multiplying the given equation by A inverse. It plays the same role as the role of the division is being played in case of number system. Actually, the concept of the inverse plays the same role as division plays the role in case of number system. We can remove A from the given equation by multiplying its inverse. So equation now is XB is equals to A inverse. Now B is still left. B is lying at the right hand side of X. So we will multiply the given equation by B inverse from the right. So see what will happen. XB of B inverse, this is equals to A inverse B inverse, right? B and B inverse is identity, so Xi is equals to A inverse B inverse, and finally Xi, X into I is X, so X is equals to A inverse and B inverse. Clear? This is what we want to calculate. So the value of X is A inverse and B inverse. We have the matrix A. You can very easily find out its inverse. we have the matrix B. You can very easily find out B inverse, then multiply A inverse with B inverse to get the required matrix XC. We did the same thing. The value of X is coming out to be A inverse, B inverse. Now we calculate, this is our A inverse and this is our B inverse. So X is equals to A inverse and B inverse. Finally, the value of X is coming out to be 1 0 1 0. This is the required matrix of the value of X is 1 1 1 0, right? So this is how we can use the concept of inverse of a matrix for removing any matrix from either the left hand side or from the right hand side. Clear? Let me once minute. A x b is equals to I. Only 1 minute. How we do it? A is lying at the left of x. B is lying at the right of x. So to remove A, we will multiply this equation by A inverse from its left. And to remove B, we will multiply this equation to the right of the given equation. So whatever matrix we want to remove, we will multiply from that side. That is why the concept of the inverse play a very important role in solving the matrix equation. So students, I think this is all about the concept of the inverse of the matrices. So I think I should stop it here. So thank you very much for your patience learning.